Hi everyone, welcome to this month's iTWO costX coffee break webinar. My name is Jonathan, a consultant at RIB, and today's topic of focus will be on composite or assembly rates. For those who don't know, iTWO costX is a fully integrated estimating solution with universal application supporting everything from hand-drawn sketches to PDFs, 2D and 3D CAD drawings, and BIM files. iTWO costX is available in a variety of feature levels, depending on the size of your business or your estimating requirements. iTWO costX offers quick and easy on-screen takeoff and measurement that can then be live linked to our comprehensive workbooks to help you save time and eliminate errors. The platform also offers a professional report writer, an auto revisioning tool to help with new drawing versions, and much more. And as you can see, there are a huge variety of file types supported by iTWO costX to help with compatibility, as we want your import or export processes to be as smooth as possible. Our latest webinar, which was posted up last month, covers the topic of zones, uses and enhancements on the zones functionality. So Ben Baker did a great job in explaining what zone properties are, what standard zones are, how to insert or create zones, assigning names and descriptions to zones. He also covered default zones for drawings, which is a neat feature, applying a zone to a drawing so that whenever you measure from that drawing, it's automatically tagged with that zone. He also then covered takeoff with zones and then how to use zones in a workbook. If you'd like to go ahead and view that recording, just hop onto the URL that's at the bottom of the screen over here. Both that one, historical webinars, as well as this webinar I'm about to take you through, will be posted up on our website as well. So this month's webinar, we're covering composite or assembly rates. So I guess let's maybe just take it back one step here. Composite rates or assembly rates. It's just a terminology that's used. Some parts of the world call it a composite rate. Some parts of the world call it an assembly rate. What is it? It's essentially a rate that is made up of other rates. So for example, over here, we're going to be focusing on building a composite rate for an isolated concrete pad foundation throughout this entire webinar. But that assembly or that composite rate is made up of other rates such as excavation, working space excavation, backfill, concrete, reinforcing steel, formwork, etc. So eventually we want to be able to build up a composite rate with all of these simple rates. So with that being said, let's see how this looks within costX. So I'll go ahead and open up costX and I'll drill down into a element or group over here, substructure, whereby you'll see at the moment I've got two different pad foundations, concrete pad foundations of different sizes, currently with no rates in over there. So essentially what we want to end up with, the end goal, is to build a composite rate that we can simply just drag and drop into these two cells. So to show you how this works, I'll start by actually dragging and dropping one of these rates in, and then once I've shown you how that works, we'll delete it all and start from scratch and build a rate library up from scratch, and you can possibly follow through and learn how to build the composite rate. So here I've got an isolated pad foundation. It's cost per number, cost per pad. Now when I drag and drop a rate in, and just simply drop it in like that and click update, usually what it does is it just drops the green rate in, which means it's live linked to the rate in the rate library out to the left-hand side over there. However, this is not necessarily what we want to do, or I guess part way there. What we want to do is we want to drop any buildup that exists in that rate. So if I just delete that rate out that cell and come out to the rate in the library, if I were to edit the rate, you'll notice that it is a composite rate. It's grayed out, which means it's got some buildup on the rate calculation sheet over here. So this is all the information that we would like to go ahead and drop into the workbook. Now, how do we do that? Let's cancel out of that. When we drag the composite rate in to that cell, we'll just hold down the Alt key on the keyboard. And when you hold down Alt and click Update, you'll notice that it's exact same rate as it was before, but this time it's blue, denoting that all of the buildup from that composite rate has now been placed into the rate sheet underneath the cell. So I can double click on that, and then it drills down into the rate sheet, displaying all the components that make up the composite or the assembly rate. So with that being said, we'll just return back up and delete that cell, and we'll take you through a process on how you might want to build up a rate from scratch. So in fact, what I'll end up doing is I'm going to delete this project rates library and we'll start from scratch. So I'm going to go to my system administration, select rate libraries, select the project rates, and let's go ahead and delete that. As I say, you can follow through if you'd like on your screen. Okay. To insert a rate library, we simply just click on the plus insert button over there, and we'll just give it a name over here called project rates. And then hit insert. So there's that new rate library. We obviously want to edit the rate library so that we can start adding rates into the rate library. So I'll go out to the right hand side and just click on this green plus insert button, and you'll see that the rate properties window pops up. Now at this stage, we're not going to jump straight into building the composite rate. We first need to add all the simple rates that make up the composite or the assembly. So for instance, the first one I'm going to add is for excavation. So I'll just type in a code of EXC. The location, I'll just choose a default location over there. Description, we can just type in excavation. The rate group, that is the folder for the rate. So let's go ahead and create a folder called excavation. The unit of measure in this case would be cubic meters. And the rate for per cubic meter of excavation, we'll just type in, say, $78 per cubic meter, and then click insert. So that's gone ahead and added the rate into the rate library. Now you can continue doing this if you'd like. You can click on the green plus insert button and add rates into the library over time. However, in many instances, it might be more beneficial to import rates in mass from, say, an Excel file or a CSV file. So go ahead and open a CSV file up to illustrate what I'm talking about. Here I have a CSV rate library, right? Now this is just the order of columns that are required by costX when you import rates into a rate library. To begin with, column A, you'll see that all of these rates have just been stipulated as an I, which means it's an item in that rate library. We then have column B, which is our codes for the rates. We then have the descriptions for each rate. Column D is the grouping or the folder structure. Column E is the unit, F is the rate, and then G is the location. So you can take existing data, go ahead and manipulate your Excel spreadsheets to match this format, and you could then import your rates in mass. So Currently, these are all the simple rates. We have not yet got to the composite rate. We'll get to that at a later stage. So this is simply just your simple rate. So you'd save that as a CSV file. So go ahead and click on File, Save As. Make sure that you choose the CSV comma delimited format, and I'll just click Save over there. Once saved, you'll need to close that file down. You cannot import the file whilst it's open in Excel. So from here, we'll just return back to our project rates over there. Now, we could, if we want to, we can go ahead and import the CSV file to create a brand new rate library. However, we've already started building this rate library, so it would make more sense to update the new rate library instead. So we can click on the drop-down arrow adjacent to the update button, and let's go ahead and click Update Rate Library from CSV. This then pops up with your File Explorer, which is just up on my other monitor here. I'll go ahead and select, there's that file that we've just looked at in Excel, and then click Open. You'll see it pops up with the Update Rate Library dialog, which allows us to choose a location. In our case, we'll just choose default location. And you'll notice that there's two options over here for the update mode. So the first one is add and update only, and the other one is delete existing rates before importing. Where that is useful is that where you might want to possibly delete older rates that don't exist in their CSV file. So presuming that the CSV file is the most up-to-date rate library with all the correct codes, most up-to-date codes, descriptions, etc. If you were to choose this option, when you import it, costX will look at the historical rates in the rate library and say, well, this code doesn't exist, so therefore in the CSV file, therefore I'll go ahead and delete it. In our case, we don't want to delete the older excavation rate that we had created, even although that's not in the CSV file. We don't want that to be deleted, so we just simply want to add an update only. So I'll go ahead and click Update. We'll recalculate the rate library, and now if I were to click on Edit, you'll notice all of the rates in the rate library over there. Right, we'll just click Update and close out of the system administration. And you'll see out to the left-hand side over here, I've now got my project rates, and if I expand it, we've got all the different folders, which was created in the CSV file with all our simple rates over there. Great, okay, so we now have a list of simple rates which we can use when building our composite or assembly rate. Now, there are two main ways in how you, well, not only two, but one of the ways in which you can build a composite rate is you can go back to your rate libraries. If we were to edit this rate library over here and insert a brand new rate, instead of just typing a flat rate in over here, you'll see that you've got this little rate calculation button over here. And if I click onto that, that brings up the rate calculation for the composite rate. So you can go ahead and list out all your simple rates over here to build that composite. As I say, this is one method. One of the other methods, which may be preferable if I close out of the system administration, is to actually build the rate up in the workbook itself. This is the method that I'm going to be utilizing. So I'm just going to double click in that rate cell to drill down into my rate sheet. And we can start dragging our rates into the rate sheet. So the first thing we're going to do is just type in over here, assembly. What is that made up of? Well, we'll start with some excavation. So we'll expand the excavation folder. There's that excavation rate, which we had added right in the beginning. And simply just drag and drop that into the rate sheet. When you drag and drop the rate in, the add rate window pops up, which allows you to choose which of the properties you'd like to use in the workbook. So in this case, would you like to use the code, the description, and the rate? Yes, we'd want to use all of that, so we'll just click update. What else are we going to need? We're going to need some working space excavation, so we can drag and drop that in and click update. We'll also then need some disposal off-site, which we can drag and drop in. Backfill with imported hardfill. We'll also need some concrete. So if I expand the concrete, let's say we need some 20 MPa concrete, drag and drop that in. We'll need some 50 mil site concrete, which in some parts of the world is referred to as blinding. Just click update. We'll also need some reinforced steel. We'll also possibly need some formwork. So we can go ahead and select the foundation formwork rate. Drag and drop that in. One final item for the purpose of this webinar, we'll also need some damp-proof membrane. So there are the components that make up our assembly. Now, the whole point of building up an assembly or a composite rate is so that we don't have to drag and drop these rates into a rate sheet every single time. We obviously want to just drop the assembly, and all of this information is dropped into this rate sheet. We now want to add some additional information above the assembly, almost like a question or answer section within the assembly, so that any information that we edit in the information section will automatically update the quantities over here. So let's just go ahead and insert some rows. And we'll start with the dimensions. For a pad footing, we're obviously going to need the length, the width, and the depth, all of which we'll place as meters. We can go ahead and type in the sizes in the meantime for this pad. So the length would be 1.8, the width will be 0.8 meters, and the depth 0.9. Then we can list out some material that is required, such as the concrete strength. This would be a question. What are the options that we'll need to type in? Let's say we'll just run with 20 or 25 or 30 MPa concrete. Those are our options. The unit obviously is MPa, and this is where we would need to type the value in. So if it was 20 MPa concrete, we want to be able to just very quickly adjust the strength over there, and based on the selection of the cell, it's later going to drive some information down in our assembly over here. Just make that bold, and that bold as well. Moving on, we'll need to calculate some rebar weight to use in the assembly beneath. So let's type in over here rebar. That will be made up of some, say, high tensile deformed bars, or just type in HD, say 25, as well as some high tensile round bars, which type in HR 12 millimeter diameter. and that is going to be measured in meters. So we'll need to calculate the length of the bars, but later we want to convert it to kgs over here. So we want the kg value in over there. So let's start by building some formulas for this. So now we've got some dimensions at the top, we can utilize the dimensions as part of this formula. Let's first get a bit of an understanding on how we're going to actually calculate the length of these bars. Here we have a reinforced concrete pad foundation, obviously with a width and a length associated to it. Now, for the HD bars, we want to be able to account for some mesh at the bottom of the pad as well as at the top. And the mesh is running in one direction with a spacing of, say, 200 millimeter spacing between each bar. So we need to put a calculation in to say, well, let's take the length of the pad foundation divided by the spacing of each bar and add 1 for the end, and then multiply that by the width, which is the length of one of these bars. So we'll switch over to costX again, and let's build that formula. Click into the formula field and start by typing in equals. Open a circular bracket. Now I'm going to use a function which is R1. What this function does is it will take the number of instances that you're calculating and add 1 at the end. So it's going to round up and then add 1. So let's use the function. We're going to open a circular bracket. And as we mentioned before, we need to take the length of the pad and divide it by the spacing. So here I can hold down the control key and click on cell C2, which is going to reference cell C2 in the formula. And then we'll divide that by the 200 mil spacing, like so. And just close that circular bracket off. So that function has now taken the length divided by the spacing to calculate the number of instances, rounded up, and then added 1 extra bar for the end as well. Now we simply just need to multiply it by the width. So we'll just times, hold down the control key and click on cell C3. So that is one portion of the formula complete. Now, as I say, we are allowing for some mesh at the top and bottom. That's the rebar running in one direction. However, if we were to return back to this diagram over here, we now also need to allow for the mesh running in the other opposite direction, still with a spacing of 200 millimeters over there. So let's return back to costX and continue building the formula. In here, we want to obviously add this, and basically it's a repeat of this formula over here. So I'm just going to copy that and paste it down, but then switch it around. So instead of referring to cell C2 over there, we want to refer to cell C3, and over here we want to switch that around to refer to cell C2 as the length of each bar. Great. Okay, so that's taken care of one mesh, but we want to allow for this value to be multiplied by 2, because we want to allow for the top of the pad as well as at the bottom of the pad. So let's go ahead and put all of this in a circular bracket and then multiply that by 2 and hit the enter key on the keyboard. So that's calculated 34 meters of HD25. We'll now move on to the calculation of the HR12, which, if I were to just return back to our dialog over here to illustrate what we need to calculate, here we have the pad footing cage, which is made up of stirrups. And essentially what we need to do is to calculate the full length of the stirrup. So we've already allowed for a mesh at the top and bottom, but now we want to allow for the cage calculation. So the full stirrup length over there, which is obviously going to be a bit of a complex calculation. So let's switch back to costX and start building that up. We'll click into the formula field and we'll commence the formula by calculating how many stirrups there are running in one direction. So again, we'll use that round one function, open a circular bracket, and we're going to need to refer to the length of here. So I'll just hold down Control and click on cell C2, divided by the spacing of the stirrup. So let's say the spacing is 300 mils in that case, so 0.3. And then we'll close that bracket off over there. Now, obviously, that is the number of stirrups. Now we need to multiply that by the length of the stirrup. So we'll times, we'll multiply, open a circular bracket, and the length of one stirrup is going to be made up of 2 times, open a circular bracket, cell C2, which is our length, plus cell C4, which is the depth. So if I just to quickly return back to our diagram over here, we have just gone ahead and said, well, let's take that length plus the depth and multiply it by 2, which is going to account for the full stirrup. So let's switch back to costX and complete that formula off. Into the formula field, we also need the equal sign, and then we'll just close that off with 3 brackets. Okay, so that is the stirrups in one direction. Now we need to do it in the opposite direction as well. So we're going to add that, and to save some time, I'm just going to copy that part of the formula, paste it down over here, but again, switch it around. So instead of referring to cell C2, we want it to go in the other direction. So that's cell C3 divided by the exact same spacing. And we need to also then update that cell there. So cell C2. My mistake, cell C3. So we're switching them around in the opposite direction. We can now hit the Enter key to complete that formula off. And we've got the total length. My mistake, I've actually got this the other way around. There we go. So now we've got the total length for all of these stirrups. Perfect, so we've got the lengths for each of these different types of bars, and now we want to go ahead and apply a factor to those lengths to convert it to kgs. To help with applying factors or any conversion factors, you have the ability to call upon constants in costX. Now, constants can either be added in yourself, or you could also, if you wanted to, hop onto our website and you'll see that we've got a TechWeb part of our website where you can download some resources in terms of documentation, installation files. There's a few how-to videos. And here I'll just take you to the samples and templates section of our TechWeb website, where you can filter to show constants. And there's various different constants depending on where you're located around the world. So in my case, I'm based in New Zealand, so I'm just utilizing that one. I've downloaded that and then imported that into my costX. Which now makes it easy. All I need to go ahead and do is just scroll down to my steel constants. And here I have a folder for steel weight round deformed. If I expand that, there's various different diameters over there. Here's a 25mm diameter. I can just drag that and drop it down into the factor column. In addition to that, I'll just minimize this folder. We've also got a round reed bar for the 12mm diameter bar. That's the constant. I'll just drag and drop that into that cell there. And to calculate the kgs of the bar, you just type in a simple formula, equals the quantity times the factor, hit the enter key, and we've now got 136 kgs of bar. I'll just, whilst I've got this cell selected, I'm going to use the shortcut key Control and B to duplicate the formula from above. And we also want a subtotal, which is later going to be used as our quantity in this cell over here. So to create a subtotal, it's quite easy. You just drag the mouse up like that. You can click on the auto sum button over here, and you'll see that there's a subtotal option over there. So we've got our subtotal. Let's make that bold. Great. Now that we've got the information section of this assembly complete, we can actually start building up the quantities within the assembly for each item rate over here. So starting with excavation, obviously the excavation is going to be the length times the width times the depth. So we'll start by clicking into the formula, say equals, hold down Control and select cell C2 times cell C3. Now the depth is the depth of the pad, but we also need to allow for an extra 50 mil of blinding or concrete, site concrete. So we'll open up a circular bracket over here. First multiply. Open a circular bracket. Hold down the Control key for and select your depth quantity, which is cell C4. And then we'll add on the extra 50 mils for blinding. Close that circular bracket off, and then hit the enter key. For the working space excavation, I'll just open up a quick illustration here. The grey part of this illustration is the concrete pad foundation. Now we need to allow for some working space excavation around the outside of the concrete pad so that we can later put in some formwork. In this case, we allowing 400 millimeters of working space excavation all around the outside of the pad foundation. Now, in order to calculate this, what we will end up doing in our assembly is we're going to be utilizing the center line of that working space excavation. And to calculate the center line length, before we multiply it by the depth of the excavation, we need to take the length of the pad foundation and then add on 200 mils on either side. So let's switch back to costX and complete that off. Click into the formula field and let's start typing in an equal sign. We'll open up two circular brackets. We'll say 2 times. We now need to work out the length. So that's going to be, we said 0.2 on the one side, plus the length, plus the 0.2 on the other side. And then we'll close that off. And by multiplying it by 2, that'll take care of both sides of the pad. Then we want to do it in the opposite direction as well. So plus, open a circular bracket, 2 times, open another circular bracket, 0.2, plus, this time we're going to add the width of the pad, and then the other 0.2 the other side. And then we'll close that off. So that's now calculated the center line length. We now need to go ahead and actually multiply that by the width of the excavation, which is the 400 mils, as well as the depth. So let's say multiply, open a circular bracket, we said 400 mils, so 0.4, 400 millimeters, multiplied that by the depth of the excavation, which is cell B4, and then we'll close that circular bracket off and hit the enter key. Moving on to the disposal of site, pretty much everything that's going to be excavated is going to be disposed off site. So we'll just put in a simple formula over here to say equals cell C15 plus the working space excavation as well, and then hit the enter key. For the backfill, that's just going to be the working space quantity. So we'll just type in equals cell C16, which is the quantity for the working space, and then hit the enter key. Concrete, that's obviously an easy one, that we just need these 3 dimensions at the top of here to multiply out and work out the volume. So we'll just quickly do that. We'll type in equals length times the width times the depth, and then hit the enter key. The 50 mil site concrete, as I say, some might refer to this as blinding. That's literally just going to be the area multiplied by the 50 millimeters. So let's go ahead and build that formula. I'll just type in equals cell C2 and the width. In fact, we're pricing this per square meter, so that should be sufficient. Then for the reinforcing steel, we've already completed that calculation. We've got 176 kgs of reinforcing steel over here. So we can just simply refer to that cell of G13. For the formwork, around the edges of the pad footing, we'll click into the formula field and start building our formula. So we'll say equals 2 times, open a circular bracket. Now this is where we need to account for the length and the width. So we'll say C2, which is our length, plus the width, close that off to circular brackets. So that has calculated the perimeter length around the outside of the pad. Now we simply just need to multiply it by the depth of the pad. So times cell C4 is our depth. And then hit the enter key. That's taken care of the formwork. The damp-proof membrane underneath the pad is simply just going to be the area. So we'll click into the formula field and say equals, open a circular bracket. That's going to be length times width, which is the area underneath the pad. And then we also need to add basically the same quantity as our formwork around the outside of the pad, around the sides of the pad. So to save time, I'm just going to refer to that cell, our formwork quantity over there, and then hit the enter key. Right, so by building the assembly this way, it makes it rather dynamic, because obviously if we change a width, let's say the width now changes to 1 meter, and hit the enter key, all of the calculations underneath that will adjust based on the dimensions of the pad over here. So just return that back to 0.8. Now this is all good and well, but we can make it even more efficient if we want to. So say, for example, we'll look at the concrete item. Here we've got a code for that concrete rate where it says CON20. If we wanted to make this dynamic, we can reference the answer to the question that we have at the top of here based on the strength. So to build this formula, I'm going to click into the formula field and say equals. I'll open a quotation mark because con is my text that I'd like, and then close the quotation mark. Now, instead of typing in a static number of 20, what I'll do is I'll add and say and cell C7 and close that bracket off. What that does is it builds the code for you based on what you answer here. So if we now adjust this to say 25 MPa, notice how the code changes for that rate over there. I'll just return that back to 20 and it jumps back to 20. We can do the same thing for the rate over here. So to begin with, what I'll actually do is I'll delete that description out, and there is a function available which can make it quite dynamic. I'm going to click on the function button, and you'll see over here there's a function called xGetRate description. So whatever the code is that will be utilized to go ahead and find the rate description in our rate library. So what do we want to use here? We're going to search in our project rates potentially, or the item code. So let's type in over here COM20. And then click insert. So you'll see it's found the description from the rate library and placed it into that cell. Now in the formula at the top of here, I want to make this dynamic. So basically just replace all of this part of the formula to refer to the code. So let's click into cell A19. So the formula is now saying it's going to get the rate description using the code in cell A19, which in itself is dynamic based on what you answer the concrete strength to be. So we'll hit the enter key over there. And I simply now just need to tell the workbook to find the rates from the project rates library, and then click update. Now when I draw back down into my substructure and we draw back down into the pad foundation, we've now got that description working dynamically. Furthermore, we want the actual rate itself to be dynamic as well. So not just the code and description, but the rate itself. And you'll see if I open up the concrete work section or group in my project rates library, we have 3 different strengths of concrete over here. So obviously as I change the strength in my question and answer section at the top over here, I want the relevant rate to be reflected as well. Now the easiest and quickest way to do this is to simply just go ahead and replace this part of the formula with your code. So now it's saying what's getting the rate using the code in A19 from our rate library and running that off to 2 decimal places, hit the enter key, and it's still remaining as 360. So far, we've been building up rates within columns A through to H in our rate sheet. There's nothing stopping you from adding additional data in the user columns of a rate sheet as well, out to the right-hand side over here. So in our example, we've got a few columns set up for embodied carbon estimating. And you'll also notice that I previously added an embodied carbon rate library for each stage. And this rate library matches the exact same codes and structure as my project rates. It's just not dollar rates, it's carbon rates. So for example, if we look at excavation, we've got the exact same code, but this time just a rate for an embodied carbon rate. Obviously, for this stage, it's at 0. And what we can do is we can just drag this and drop that into the embodied carbon rate column for that section, and it'll create our formula for us at the top. But again, we don't want to refer to a static code. We want to make this code dynamic. So I'm going to delete that code and refer to the code within the workbook itself. So as these codes change, obviously the rates out to the right-hand side will change based on whatever code you're using. So I'll just hit the enter key over there. For the total, that's just going to be the embodied carbon rate multiplied by the quantity. So let's build that formula. We'll say the quantity of 1.37 cubes multiplied by the embodied carbon rate, and then hit the enter key. That's taken care of that. That's for the one stage. However, for the next stage, we've got a separate embodied carbon rate library, again with the same structure. I'll go ahead and find the excavation rate, so 2.01. We'll drag and drop that in. Use that rate. We'll replace the static code with a dynamic code by referencing the cell over there, and then hit the enter key. For the total, we'll just build the formula to say equals quantity multiplied by the embodied carbon rate, and hit the enter key. You may want to just increase the decimal places displayed over there potentially. In fact, we can do it for all of these. And once you've got that in place, it's quite simple. You can just drag and drop this down and use the shortcut key on the keyboard, Control and D, which will just duplicate those formulas down for you. So that's taken care of the embodied carbon columns, just additional data. And one final thing that I also want to do over here is I've got a package column. Currently, my workbook is in an elemental format, but I want a bit later be able to switch from an elemental format into a trade format. And to do that, we would then just need to assign some trade codes against each of these items. If I go ahead and click on my codes tab, I've got a code library already set up with all my different trade codes over here. It's quite simple, just a drag and drop process. So the excavation needs to go to the groundworks trade. I'll just copy and paste, drag and drop that in. Now, in addition to drag and dropping in, you can also copy and paste that down. So that's going to be pasted against these three items over here. The concrete item needs to go to the concrete trade. So we'll just code that up with concrete. The 50 mil site concrete will be the same. So I'll just use Control D to duplicate that. Reinforcing steel will go into the reinforcement trade, so we'll just drag and drop that in. Formwork will need to go into the formwork trade. And the damp-proof membrane, that will just go into the groundworks trade. We now have a complete assembly, which is quite dynamic, it's quite smart. Coming back to the concrete strength as an example, if we were to change this to say 25 MPa, just take note before I hit the enter key, the code, the description, the dollar rate value per cubic meter, as well as the embodied carbon rates over here will all dynamically change as I hit the enter key. So I'll hit enter and everything's changed to reflect that. Concrete 25 MPa, the description, the rate, as well as the embodied carbon rates out to the right hand side over there. And if obviously I had to choose 30 MPa, the same thing will happen over there. So I'll just return that back down to 20 and then roll back up one level where we've got the complete composite or assembly rate per number. Now, to save us having to do that every single time, we can now save this composite rate library back to, we can save this composite rate back to the rate library by right-clicking over that cell, and you'll see that there's an option over here that says copy to rate library. When you do that, the rate properties window will appear, asking you which rate library would you like to save it to. I'll leave it set to project rates. The item code, I'll just go ahead and type it over here, pad FTG for footing. Location I'll leave set to default location. The description I want to amend because currently it's pulling the description from the workbook description cell over there, which is quite a specific size, whereas we want to be able to use this composite rate for all the different sizes in future. Just have one composite rate that encompasses all the sizes. So over here, I'm just going to literally call it isolated pad foundation as my description. The rate group, I don't yet have a rate group that I'd like to put my composite rates into, so I'm just going to type in an elemental group of the substructure. And the unit of measure, of course, is number, because this is a rate per pad foundation. Quite importantly, the maintain live links, that checkbox needs to be ticked because those are these rates over here, if I click on the green book, all of these rates over here are currently live linked to our simple rates in our rate library. If you want those to be maintained, then you definitely want this checkbox to be ticked over there. Let's click insert, which will now add that to our rate library out to the left-hand side. If I expand the project rates, there's that new group. If I expand it, there's our new assembly or composite rate, which we can use. Actually, we can go ahead and use it for the other side. So I'll drag this, hold down the Alt key, drop it down into that cell, click update, which will take all of the build-up from the rate library, drop it into that cell. We can now drill down and adjust accordingly. So this size is not 1.8, it's 2 meters by 2 meters by 0.9. And as I'm changing that, the entire assembly is adjusted beneath over there as well. And maybe, you know, this one is 25 MPa concrete. And then we can return back up. Finally, we just need the quantities over here to go ahead and calculate the total cost as well as the total embodied carbon output for these two different elements or pad foundations. So I'm going to switch over to the ground floor plan over here and very quickly just measure these pad foundations. I'll start by switching some layers off first, the pad foundations off, and then I'm going to click on the invert button so that we're only left with the pad foundations. We'll start with the 800 by 1800 by 900 millimeter pad foundation. Now you could, if you want to, just switch to point mode and go ahead and click and register a count for each of these pads. However, what might be quicker is to use the auto count feature. So I'm just going to click on auto count, which will allow you to capture a pad. So I'm just going to simply go ahead and draw a rectangle around that pad there. Tell costX to search for any image that matches that. It's found 47. I'm going to click Save Accepted. I'm happy with that. And that's taken care of the, you know, there's 48 of that size. And finally, for this size, we'll also use the auto count. Click on capture. I'll just maybe zoom in and just capture one of the bigger sizes, like so. And I'll tell costX to go and search for that. Okay, it's found 30 of those. I'll click Save Accepted. And we've counted all those pad foundations. Now, when we switch back to the estimate, we want to obviously use those quantities. So I'll go ahead and drag that size in there. I want to drop down the count, click update. And as I do that, notice the total cost is calculated for the dollar value, but also the embodied carbon total cost out to the right-hand side over there. So we'll just drag in the other size, click update, and now that is complete. The important part or takeaway from this is the assembly rate. That rate can now be dragged and dropped against any size pad foundation, and it can be used for this estimate as well as any future estimate. So yes, you might need to spend a bit of time building the assembly or the composite rate, but once you've completed that and you've made it dynamic, it can be used in an extremely efficient manner. And that draws an end to this month's coffee break webinar. Thank you very much everyone for attending, and we'll see you again next month. Cheers.